Awesome. So I'm sharing screens again. Can you guys just confirm that you can see the lecture slides? So again, it's just in screen share in slideshow mode, so it should be full screen. Just FEA training 9:10. Yep, awesome. Thank you. All right, so the recording is going. To everyone on, thanks for coming in. So this is going to be our second week. We had CFD last week. This week we're going to be focusing on FEA, where we've got 4 sessions kind of lined up, 3 hours each. We won't necessarily take the full 3 hours. Today we're going to be focusing on geometry preparation, similar to the CFD portion using SpaceClaim, but we're just going to be preparing the geometry a little bit different for mechanical. Day 2, we'll be taking that tomorrow. Bit of an introduction into meshing, contact. I've got a couple of linear analysis components and we'll be playing around with them. On day 3, we're going to get Sam in to help you guys out with some nonlinear contacts and materials as well. And then on day 4, we've got Peter Brand, because he's going to be helping out with linear dynamics. So we've got different people coming in. So do ask everyone how you can potentially get their help as well, because everyone's got different experiences. So I'll start off with just a couple of minutes. I'm not going to go too deep into this. Just a bit of introduction about ourselves. So we are Leap Australia, founded around 1996, 50 staff around Australia and New Zealand. And we've got thousands of commercial and academic clients as well. We're a channel partner for Ansys and some other software as well. We're not just a sales organization though. We are focused on training, technical support, consulting, and we also do things like guest lectures as well. Right. We implore you to stay connected with us on social media. So I'll be sending everyone links out, but you can always have a check on those socials. We're pretty active on YouTube and LinkedIn and Facebook as well. The reason you want to be able to, the reason you want to actually, keep us on your list is that we do talk about careers that we potentially got available coming up. We're always looking for interns for the offices, and please do check us out there. I'll chuck this on the chat right now. So what I'll be doing is after the recordings, I'll be adding the playlist to the actual recordings to this YouTube playlist that we've got. It's got the CFD tutorial, the CFD presentations from last week, so everyone should be able to access it. All right. So what we'll try to do is that for this whole week, I'll just throw the raw videos, the raw recordings up, and then after next week, probably in March, I'll get one of the teams to actually cut up the videos and throw them onto the actual Learning Hub as well. I do have some links to the Learning Hub. We'll be talking about that in a second. It's where you'll be able to find a lot of our material. Right, so what do we actually do? We try to provide the best-in-class software, right? So we're going to be focusing on today on Ansys simulation, but we also have platforms for things like PTC, so to help out things like, with like CAD, product lifecycle management, Internet of Things, and augmented reality as well. And you can see at the bottom, we've got a range of complementary engineering products as well, right? Discrete element modeling, 1D fluid network. So if there's anything that you want to do regarding to computational, engineering, please do shout out to us. Right. Why do we focus on Ansys? So the reason that we focus on Ansys is because it's the market leader for simulation and it covers a wide range of actual physics. We're not going to be going over every single physics option. What I wanted to talk to you guys about, though, is what we can do with the structural solver, right? So you can see on the left-hand side, we've got a bunch of different topics, and you can see, on the right as well, a couple of animations about what we can do with the software. So, the reason that we're using simulation is that we can start to design these different concepts. We can start to test them as well and understand exactly how they're going to perform. So what I'm going to do, so I'm going to get it off this. So you can see on the left, we've got an impact of an actual jet coming into a concrete wall. So, understanding what the strength requirements are, if we've got a safety critical building, something like a nuclear power plant, as you guys can understand, instead of building and testing multiple walls, different materials and different aircrafts, we can use simulation to run through the event very quickly and get an understanding before making that final product. On the bottom right, we've got a topology optimization simulation. So we've got some sort of geometry and we're removing material away to make it lighter. In this particular case, it's a component of a helicopter. And as we understand, if we can make components light on a helicopter, we can start to use less fuel and we can travel for longer periods of time as well. Ansys also has some software around 3D printing as well. So if you've got a metal component that you are 3D printing, we can actually use simulation to actually simulate the printing process to make sure you don't have any broken parts. And on the bottom right, we've got a rigid body movement of a jet thruster. So again, we can simulate the range of motions. We can also do a stress analysis on these components as well to understand, what's happening to the stresses when it's moving. Are there any hotspots? We had a chat about the fluid solver last week. So you can see again the topics on the left-hand side. We won't go into it too much detail today, but if you do need any help, feel free to reach out to us and we can always talk you through your actual projects as well. Electronics is going to be covered next week. So if you do have any projects that require electronics, again, you can see a bunch of topics on the left-hand side. Come out. Mohan's going to be helping everyone out there, and we'll be able to have a chat with him regarding your actual projects as well. Now, the power of simulation, the power of Ansys as well, is that it's not just a single physics solver, right? We can start to bring all of these components together. So this is an example. We've got a flow over a cone, right? We've got some, and it's in some water, right? We can do a turbulent simulation using CFD to understand what the flow structure is and what the surface pressures might be. We can then start to look at things like a vibration analysis, right? Understanding what the modal analysis of it might be to understand if, because of the CFD, because of the flow around here, are we in any problem areas, right? Or do we have any structural modes that might get us excited? And then we can take that information, we can start to do a stress analysis to understand what the actual stress might be. And if we can identify hotspots, we can then go in and start to make some changes, right? Whether it's making changes to the geometry or the flow physics or changes to the actual situation as well. Right, so when it comes to getting involved, so we talked about this last time as well. We help out students as well as commercial customers. So if you have a project and you're running into some problems, do reach out to us on support. Give us a little bit of information about what your actual project is, what you're doing, where you're at in your career at the moment, and also include your actual supervisor. If you want to have a chat with us before you actually start your project as well, again, reach out to us on support and say, hey, my supervisor said this is what I want to do, this is what I need to do, and I want to figure out, if I'm on the right path and do I need any training as well. Now, to some students out there in Melbourne and I think in New Zealand as well, looks like we're both in lockdown for a little bit. There is a free student version, so you just Google Ansys Student. You'll be able to find it over here, and you can actually download the software, install it locally with the licenses as well, and you'll be able to use it. It is limited to a certain amount of nodes, but for the teaching purposes, I think it should be fine. And for resources, we've also got a YouTube playlist with plenty of videos to help people out. We've got a blog for the FEA portion. We've got a CFD blog as well. And we've also got a product design blog, right? Ansys do have a bunch of their own content. So they've got this learning forum. So you can actually hop on there and start to learn about different fluids or different topics that you may not have had at university. Ansys also have a bunch of YouTube channels. They've got a blog and a magazine as well, so you can keep up to date with what's out there. They also have access to what's called this learning hub. This is what they've created as well. But we've created our own learning hub. So we'll be having a look at that because that is where all of our content will actually be located. Right. So if you do a quick Google search for the Leap Learning Hub, right? If you come to our Leap website, you'll see it on the bottom right over here. So you can go log in. It'll come to this page. If you're new, register on the right. Existing users can just use the left. You can click on the front page here. We've got a couple of different topics. We can actually access the support email address, or you can fill a form out and it'll get sent out to us as well. Additional resources before and also links to the student version. If you click on structural, it'll take you to the structural page. And here you've got all your tutorials. So you can scan through. We've got some pre-processing tutorials that we'll have a look at. So we're going to be focusing on space claim today. We've also got some specific physics as well. So if you guys are finding for your project, you need to have a look at vibration, have a look at the actual training material here, just download them. They've got lectures as well as the tutorials and the input files. And where it's appropriate, we've got some videos that we've created as well. Again, optimization, and at the bottom, we've got some getting started material as well. If you do go to the very top, you can hover over one of the tabs and you can clearly see what we've got, and you can just click it and it'll go straight to that component as well. Right, so that's how you can kind of get through there. We'll be looking at the space claim tutorials today, and we'll be going through and actually running through some of these tutorials as I do my demo. But by the way, the Learning Hub, so I got a couple of emails. This is restricted to Australia and New Zealand because that is our territory. So if you're outside for the particular reason, you'll have to use a VPN to log in as well. Right. The other thing that I always recommend people do is always look at the help, right? So if I go into my start menu and I just type in help, I've got access to the Ansys help. This is the online version. There is a local version as well. I've got a couple of things starred over here, but you can find it on the left-hand side. And the reason for that is because you can have a look at things like the user guide, and it'll give you a lot of great information as well. So as an example, if you're unsure about something, you can have a look, say, specifying geometry. Maybe you're trying to do a 2D analysis, right? You can actually click it. It'll give you a bit of an explanation about what's happening. You can also use the search function to search for that as well. It's got information about how to get you started, and in the user guide, it's got some best practices. If we take a step back and look at the mechanical APDL guide, so APDL is the actual solver itself. You can then start to look at it in a lot more. You can have a start to look at the theory information behind it as well. So if we look at the structural analysis, you can actually start to understand what the element is, what it's doing, what the actual solver is doing in the background, how are these contact elements being created. And you can start to look at how we can apply these different types of analyses as well for your project. So definitely have a read through that. There are a lot of information. There's a lot of equations as well inside here. So if you are doing a project and you need to actually reference what the fundamental equations are that are being calculated, you can actually reference the Ansys help guide as well. So yeah, we've got a bit of information there. You can click through it at your own pace. All right, so what I want to do, I just want a quick overview about what we're going to do with Workbench in Ansys, and then we'll get into the geometry preparation side of things, right? So just a quick summary, a couple of different ways that we're going to be using Workbench. So I'll fire up Workbench and I'll show you what's happening there as well. The reason we're using Workbench for a lot of the structural work is that we can start to do things like transfer information from a static analysis over to a modal analysis. We can set up parametric studies, so we'll talk a little bit about that. In the background, it organizes the actual projects and the files as well, and we can perform things like multi-physics analysis within Workbench. There are ways we can do it outside as well, but generally the easiest and the quickest way is within Workbench because a lot of the GUI is pretty intuitive. And you can talk to us a little bit later on if you've got a particular project that requires high-level multi-physics analysis. You can see here the different analysis types that are available. So we're going to be having a look at the linear analysis today and tomorrow, and then on the other days on Wednesday we're going to have Sam talk a little bit more about the nonlinear aspect of it, and then Peter's going to be talking about some of the dynamics as well. So we're just going to be focusing on some of the fundamentals. We're not going to go too deep into them, but if it is a part of your project, again, do shout out to us. We can also do thermal analyses, magnetics, electrical, and again multiphysics as well. So when it comes to the finite element process, the general process is normally we've got some sort of CAD geometry of some sort of idealized system. We're going to then prepare that geometry. That's what we're going to be focusing on today. And we're talking about why it's important to prepare the geometry. We can then create a mesh on our component as well. So we'll be talking a little bit more detail about that tomorrow. And then from there, we can apply the analysis depending on our boundary conditions to understand what the forces, what the stresses and strains might actually be. Right. When we think about our linear analysis, so we've got some sort of stiffness matrix and we're trying to solve for that. Right. In this particular case, we've got K, which is the global stiffness matrix, and we've got F, which is the actual forces applied, and X is the displacements in our actual system. Right. When it comes to the basic procedure, we're going to go through a couple of different steps. So understanding what the initial decision is, right? What are we actually trying to do? We're going to go through the process of then pre-processing the model and then looking at the solution and going through some of the post-processing side of things. So hopefully by the end of the week, you've got a good idea about each of those different steps, what we can actually do as well. The analysis types, what are the boundary conditions, what are the inputs and outputs that you might need to actually consider for your particular analysis. And it's really important that before you actually open the software and actually start, you do have a solid understanding about what's happening in the background. What information do you need? What do you have? Do you need to find some information as well? Right. So when it comes to geometry prep, I'm just gonna instead of going through some of the slides. So I do have a lot of slides, by the way. I'll just be using this as a reference to go through some of the material, and I'll be using it to kind of prepare everything. All the slides are available in the Learning Hub. So if you go to the Learning Hub here, just log in. If you go to webinars at the top and go to the online training. Right, we've done online training before, so that's why you can see some of the old stuff. The FEA presentations will be there as well. After the whole session, I'll make sure to go in and update everything if we're missing something. Right. So I'm just going to open up Space Claim, and I think we're just going to start with a couple of things. And I've got some examples. So what I'll do, I'll just be talking through the examples as we go through the actual process. Right. So this is similar to, the Space Claim interface is similar if you were here for CFD as well, right? So we're not going to be doing anything too special, but the way we go about actually preparing the model can get a little bit different. So this is the interface. We've got the ribbon interface at the top, sketch icons. We can go through our design aspect of it as well. If we need to push and pull, we'll be talking about that in a little bit more detail. We also use things like the measure functionality. We use the prepare and the repair functionality in order to prepare the actual model. And then when we're happy with it, we can export it out to mechanical from Space Claim, or we can open it up in Workbench. And I'll show you both two ways of doing something like that as well. We can also do detailing in our in Space Claim, right? So if you need to make some quick drawings, and if you've got sheet metal components as well, you can also do that, right? All right, so let's just start by making a couple of different components. So what I'll do, I will first just make a couple of components, right? So I'll be looking through one of the workshops. So I'll try to keep it similar to what you guys have access to. So we'll try to create this component to begin with using some of the sketching features. Afterwards, what we'll try to do is have a look at geometry and start to repair the geometry, right? If we have any problems with it, we can do some preparations if we've got an existing model as well, right? So let's start with just creating something, right? What we want to do is that we've got our triad system over here. I'm going to select the y-axis and I'm going to go into sketching mode. Right. The sketch tools kind of hop up, And we've got our traditional sketch tools, right? So this is similar to what you've got in your CAD softwares, right? Something like SolidWorks, CATIA, Creo. The difference is that you'll notice on the left-hand side, we've got this structure tree, right? So I can, pull something out to a certain amount. On my keyboard, I can type in a certain value, it'll snap to it. And if I hit the tab button, I can tab through different components. Right, I can just hit enter and it'll generate the sketch for me. If I exit out of it, right, and I want to use my pull feature here to pull up that sketch, one of the key things you'll notice is that I've just got the actual feature, right? So I don't have a distinct list of all the tools and all the steps that I've done. We can do that with block sketching, but we'll talk about that a little later on. So the difference, that can be interesting. It can be very freeing because you don't have to go through and follow a huge amount of sketches. I didn't necessarily need to, dimension everything as well. It is something that we can do, but we've got the flexibility to play around with these types of models in SpaceClaim. And by Control Z, I can just go back a couple of steps to my sketching plane as well. All right, so look, I've got this component here. I can use my dimensioning if I wanted to go in and pick up two specific dimensions. I'll make sure to put that in the right place and do that as well. I can then go in and create my rectangle. I'll create it 20 mil here, 10, right? So I'll leave it off axis for now, and I'll go into my sketching mode, right? Go out of my sketching mode. You'll notice as well, if I go back, I had a bunch of curves, a bunch of sketches, because they were all closed off. When I exited the sketching mode and went into 3D mode, it automatically converted it to surfaces as well. If I had something that wasn't fully enclosed, so I have something like this and I just deleted one of these lines and I go back, so I'll just hit D on my keyboard. It takes me into 3D mode. You'll notice as well there are a lot of keyboard shortcuts. When you hover over something, it'll tell you, example, P for pull, M for move, F for fill. If you go to our sketches, R for rectangle, C for circle, right? And then you can easily create your own if you wanted to. So what I wanted to show you though is that when I've got a component that isn't closed, it creates these curved surfaces for me so it doesn't fill it in. If I use my pull tool, I can actually select those curves and I can pull something up and it'll pull it into an actual surface, right? If I've got surfaces, I can select both of them. I just control select both of these and I can pull it up as well, and it can pull into a certain shape. You notice there's a bit of a option there, so it tells me, do I want to give it a particular parameter? And I can do that. So if I go Control Z, I can select both of these, arrows pointing up. I'm 15 on my keyboard, enter, and it'll pull it up to 15. I can select that particular component and use something like a ruler, to enforce a certain dimension as well. So let's just say from here, use the ruler to here, I want that to be 15. And then from here, use my ruler again to here, I can make that be 15 as well, right? So you'll notice, it's very flexible in the way that you can do it, right? I didn't need to go back necessarily to the sketch and make a bunch of changes and align this wherever I wanted to. I can just pull and push on some of these components and then make them bigger or smaller as well. I was able to use that line to create a surface, and then again, similar to before, I can use a pull feature and pull onto that as well and generate, some of these surfaces as well, right? And you'll notice, it creates multiple solids. Right, I'll just delete those off. Question, shortcuts for SpaceClaim. So yeah, if you hover over a button, you'll find that it'll tell you M for move in brackets if there's an actual shortcut. As an example though, Plane doesn't have one. I often like to go in and create one for Plane because it's something that I do all the time. So let me find it. So we can go into customization here, shortcuts. We can add one. The command that I use is, I think, Control W. Actually, we'll go here, pick out Plane. What do we have here? Command, let's just find it. Where are we now? All right, so we've got the plane, and I'll create the shortcut Control W, and I can assign that. There you go. So now what I can do is if I select something, I can use that. I can use my sketch, my design, sorry, to create a plane, right? If I delete that, I can select it, Control W, does exactly the same thing. If I select, say, two faces, Control W, it'll put a plane in the middle as well. How to copy solid roles, yeah, so that was one of the things I'll do later on as well. But what you can do, you can select it, and you can use the move function here to move something around, right? XYZ directions. If you select the whole body though and hit Control on your keyboard, you can create a copy of something as well, right? So you can then start to move it around however you need to, right? So that's how you can do that. All right, so let's continue creating this sketch. So after I've done this, what I'd like to do is create a sketch and create some holes and extract some surfaces as well. So again, we can go back to our sketching. I can select that and hit my circle button. At the bottom here, I've got some options. Plane view is V. So if I select that, it'll snap me in, and I can kind of move it into however I want. So I'll use a little bit of dimensioning in this particular case. So let's just say I create my circle. I can go to my dimension and dimension what the parameters here might be between these components, right? So let's do that. So then I can select it. Let's just say I want to make it 5 instead. So let's delete that parameter. And I want to take the radius there, the diameter. I can make that 10. I can go in and say make that 5 as well. Right, so you can then go in and start to make some changes and play around with what you've got. Right, let's just make this a little bit bigger. It's good to go. The next thing that I want to do, so let's just say I want to create the same component on the right. I can use my mirror function here. I can select a plane and an object, and it'll mirror it for me. I might need to go in and give it some dimensions as well, depending on what I'd like to do. If you are, in a specific tool at the top, you'll notice, by the way, it has a couple of icons. Hovering over that will give you a bit of an explanation about exactly what it's asking you to do. And you can notice that at the bottom as well. So again, I want to select a mirror. It'll change the icon. I've got a couple of different options here. I can mirror a body, I can mirror a face, or I can mirror a component as well. And as I'm going through these things, you'll notice as well on the left, I've got some options, right? So in this particular case, it merges it and it can create some relationships, whereas I don't have some options for mirroring components as well, right? So I've got that. Now, the next thing I want to do is create a rectangle here. I can go in, I can, manually draw a rectangle if I wanted to. You'll notice I'm snapping everything to grid on the left-hand side. We've got some options. So let's just move this away. I can untick that and I can, again, go in. The other thing you can do, again, similar, you've got some options here, right? So you can select a bunch of these features and we can make and extend something in. I want to, just cut the top off here. I've got this construction line that I can create, right? That way, when I select all of these lines, right? So let's select them. 1, 2, 3, 4. I can easily drag that in. Let's drag it in, say 5 millimeters. No, that's way too much. Let's just drag it in 2 millimeters and it's good to go, right? D on my keyboard takes me into 3D mode. There are some shortcuts, so H brings me into home as well, right? Go in and select that. All right, now that I've got some surfaces, what I'd like to do is go in and use my pull tool to pull something in. So the pull is a pretty versatile tool. I can pull things in, but I can also select it and use it as a cutting tool as well, right? So I can cut through whatever I've got. Again, similar to before, I can cut through, -5 millimeters. I can cut through using a ruler, right? I want a ruler 5 mil into there, or I can cut through up to a specific surface as well, right? So I can do that. What I'll do though, I'm just going to leave that one. Control Z, by the way, just undoes everything. We'll leave that for now. We'll cut through this. The other interesting thing that I can do, I just want to show you guys some of the things that you can do with these tools. If I select that, I can now that I'm selecting an edge, I can actually copy that edge out, right? So if I select that option, I can copy it out. Let's just do it by 3 mil. and I can select this new surface that I've generated and pull it up, right? So let's just make this 5. So depending on what you select, you'll notice that you can then start to push and pull different things. If I select a face, I can pull that out, right? And I've got some different options for there. You'll notice again, options on the left. If I select an edge, I've got some different options, right? I can even select if I wanted to, I can select a point and I can pull a point out to create a line. That line can then be pulled to create a surface. The surface can be created to pull a geometry as well. Right. So we've got a couple of different things that we've created here. Now what I want to do is go in and start to make some changes to it, right? So if I want to go in, I can select both of these, make some changes. I can use my split body tool at the top. I can split it away, right? And if I select it, I can use my move tool to move my component around, right? I can, again, go back to my pull tool. I can then start to add things like radiuses around here, right? So I can add something in, select a bunch of these faces here. If I type, say, 2 on my keyboard, press enter, it'll give me a 2 mil radius everywhere. I can then go in, say, let's just say I want to select some of these edges. I can use my chamfer tool to do that as well, right? So I can do that, and you can see, so I can play around with it depending on exactly what I want to do, right? And again, I can go and use that surface, extrude something, move it around, and play around with it. If I'm not happy with that, I can go in and use my fill tool to fill in what I've got, right? I can say take that component like I saw before, and I can copy it. Let's just say I want to hide this. I can make this a bit smaller. And one of the things that you'll notice is that because I've got everything in the same component, when I changed the diameter here, it combined everything together. So what I like to do, if I've got a body that I know I'm going to be independently moving around, I can move it to a new component. So now when I make a change, it doesn't automatically merge that solid together. All right, so what we can do now is use, let's just hide that. We can maybe pull this out a little bit. And we can use some of the tools up here, right? So if we wanted to intersect, we can use, for instance, let's use the split body, where again, I can split that from that surface, right? If I hide that, you'll notice it creates a separate solid for me, and I can delete that if I wanted to, right? And if I again go to split, I can do it the same way, and it'll get rid of it. So I think that's already split, which is why. Use split body. Split that from there, and I can actually remove the material internally as well. So that way when I hide it, I've gotten rid of that material. Right. If I wanted to combine it, I can use the combine tool and actually merge both of them together. Oops, select that, merge, put them in, and now we've got one body. Alternatively, I can also use the combine tool as a cutting tool as well. So again, I can use that to cut away the two material. All right, so if you wanted to mirror something as well, so Merson, you can create an axis right from there. So you can say click that, you'll create an axis and you'll generate the axis there, and you can select that later on. Or you can use the plane tool, right? So I use the plane. Let's just say I want to mirror this object. All right, I'll move this around. So I've created this plane here. I can use my mirror tool to select a plane, select a component, and it'll mirror that around. If I mirror a component, it creates a relationship between them as well. So what you do to one, you can kind of do to the other one as well. Right. So the other thing to think about is that you don't necessarily need to be thinking about fixing the sketch as well, right? So it's a little bit different when you come to thinking about some of these things. You can just directly play and move, your actual component as well, right? So again, we can touch that, move it around, move it into place, right? So hopefully that's given you an idea about how you can create different types of geometry inside SpaceClaim. So we can use a lot of the sketching tools at the top, similar to probably what you guys have probably thought about and used in SolidWorks. That's not very different at all. The biggest thing to really wrap your head around is that we don't have this feature tree. So let me show you though how you can generate something using a feature tree. So it's a little bit different. We're going to go into what's called this block sketching over here, right? You'll notice on the right-hand side, something will pop up for me. So it's recording exactly what I'm doing. There are some features that aren't supported, like some of the sheet medaling tools. So it's not fully supported yet, but it'll be improving as we're going along. So let's just say we want a rectangle. We select this surface. We'll do something similar. We'll define it from the top. We will create something that's say 20 by 20. We'll go into our dimensions and we'll just create some dimensions for us as well. Right, probably don't need a dimension. What we'll do, we will put that in there. Let's actually just offset it as well. And then what we can do is let's create a circle in the middle. And we can dimension that as well. Right, we can get out of that. We've got these two options. I want to take the outside. I can use my pull and hit 5 mil. You notice as we've been doing these things on the right hand side, it's been capturing all my dimensions, right? So I can go into here, generate this by 10 instead. And I can hit the play button and it'll regenerate that for me. I could go into even the sketch over here. Instead of 5, let's make this 4, generate the whole thing, and it'll go through that process as well and regenerate everything for me. I can make things like parameters in this block sketching mode, and we can import it into Workbench as well. So if we need to do some parametric analysis where we're creating geometry, we can definitely do that. Right. Again, similar to before, so we can take something, use my design tool. So if I use my move tool, let's just say we move this up and around, everything's being recorded for me over here. I can take a surface, right? Control C, Control V, and I can copy and paste it, and it will actually copy that surface for me. Let's take that. So let's delete that one, and let's take that surface, Control C, Control V. All right, that doesn't quite like me doing that at the moment. So it's just generating an empty thing over here. So let's delete that. Let's leave that for now. So there might be, like I was saying, a couple of things that you might want to do that might not quite be there at the moment. If I take that surface, there you go. So instead of Control C, Control V, I can select that surface, use the move tool and hit Control will create separate ones for me, separate entities for me. Again, I can select the top, use my fill tool, can bring that, use the pull, push it all the way down. Let's just say we make this a little bit larger, right? It combines everything together. Or I can use my, split body, and I can split that body using that surface there and get rid of it altogether. And again, you'll notice everything I'm doing is being recorded, right? The block method is just a way that we can record what we're doing over here if we want to make parametric changes to the geometry. Cool. All right. So now that we've seen how we can create some geometry with Inside Mechanical, the next thing that I want to have a look at, though, is how we can use some of the repair functions in here. So sometimes when you've got geometry that comes in this particular case, I'm just importing something in. Sometimes you might export it out as IGES files. There might be some problems with it. And you'll notice here everything's come in just as a bunch of surfaces, right? So it's all one color. I can Control A. I often like to randomize the color just to give me a good idea about exactly what I've got. If I take a section view through it as well, you'll notice section mode. We can move it around. You notice everything is just a bunch of lines as well. So that'll change a little bit when we create it into a solid. Right. So the first thing that we'll do, we'll go over to our repair tab, and we've got a couple of features here that we can play around with. So the first thing is that we'll use our solidify features. So depending on exactly what you want to do, what geometry you have, you might want to go through some of the tutorials and identify what features you might need to focus on. Right, so this is going to stitch everything together into one surface, right? So you notice now everything's stitched together. I can use my tools here to identify things, right? So I don't have any gaps, but I do have bigger missing faces, right? I've got 2, so I can hover over it and I can left click and it will fill it in for me. Alternatively, I can hit the tick button and it'll just try to do everything. Or if I go back, I can use my navigate feature here if you have a lot of them, and it can actually highlight what's happening and you can use a zoom to fit feature as well. Sometimes some of these features may not work, so you might need to go in and individually, fix some, and then there might be a bit of a process to say fix the others. Right. So now that we've got this component, it's a solid. Again, if I select my axes, I can go into section mode here, and you'll notice that the geometry has changed quite a bit. Right. So now it's a solid geometry. A couple of things that I might want to do. Again, normally what I'll do personally, I'll go through a lot of these processes, right? So split edges here, what I'll do, I'll create a split edge and I'll show you what's happening. So if you go to my split edge, you can intentionally create one if you want to as well. You can cut that, say, into 4. And what happens is that it will split the actual edge into all of these different components here. You can even go to the display. That's right. So the benefit, the problem with that, you notice we've got a couple of edges. The problem with that is that the mesher might have problems generating, these fine elements across, here, right? Or you might be splitting unnaturally around some of these edges. So generally going in and fixing the split edges, getting rid of the vertices. We've also got things like extra edges as well, right? Again, sometimes they might be appropriate for manufacturing, but for analysis, it might want to put a very small element between here, which can cause you problems with your actual meshing quality as well. So by going in and making some changes, we can definitely go in and start to fix it up, right? So if I've just got a solid here. If I was to create something, I can select my duplicate and it'll pick up the fact that I've got a duplicate face and it can get rid of it as well. And there are some curves in here as well. So I'll often go through. There aren't any particular problems in this particular case, but you can go through and fix any small curves or problems as well, right? And then now using your features, you can use your merge faces function, right? So we'll try to merge it into one, or you can easily use your design tabs as well. So if you can select that, use the fill tool, it'll actually pull the two edges together and create an edge for me, right? Or again, similar to before, you can use your design tools to go in and make it a little bit larger as well, right? Or just get rid of it altogether. So you can go in and use the repair tool to go in and pick all these things up. We can identify things like small faces as well. So if we go over here, we can start to increase what the maximum size might be, and it can start to identify where we might have some small faces, right? We can go zoom to fit, and then we can go around and identify where we might have some problems. We can do exactly the same as well for small areas, right? So if we have something that has a small area of something like 0.1 millimeters, again, we might have some problems trying to generate a good quality mesh. So we can start to go in and actually reduce them as well. Again, you can use things like the simplify. So this will start to simplify some of these areas, right? One of the things that you'll notice if I select this, it identifies it as a spline, whereas some of these other faces identifies it as a cylinder with a specific radius as well. So again, when you go in, I've sometimes had sometimes had problems where, because it identified it as a spline and I had curvature controls on there for my meshing, it would put a lot of very small elements in here because it thought it was a very small curved component. Right? So you can go in and start to simplify some of those conditions. You notice straight away it caused a bit of a problem for me, so I can Control Z and maybe you can just get rid of it. And we can leave this as a spline if we need to. Right? In exact edges as well, again, for us, it might not be a problem, but in reality, because of tolerances, there might be actually a small gap between those two edges as well. So often go through, make some fixes. Again, straighten any components that might be off axis. So you can see here the angle is only 1 degree, right? It'll straighten all of those things up. Go through and fix all those problems. If something can't be fixed, by the way, if you select it, it will highlight and it'll give you an idea about where it actually is. And then you can go in and understand, all right, what's actually happening around here. Maybe instead of fixing this face, can I maybe get rid of this component, right? Can I fill that up? If I select these two faces, maybe can I get rid of it? No. Maybe I need to make some changes to the actual geometry as well. Or I can go in and start to split some of the bodies up. Well, again, go through some of the relax and some of the tangency features as well. Right. After I've done something like this, again, you can go in and then start to add, components. So you can select the radiuses around there, right? The edges around there, and go in and create your radiuses or your chamfers, or take something, and if you need to copy an edge, you can copy that across and make some changes to it as well, right? Or just say we copy that. Sometimes it doesn't work. Copy the edges between the two of them, and we can use the blend function to blend geometry between them, right? All right, so go through a couple of questions. Dimensions of an object, what is the best way to do it? So if you want to investigate the structural dimensions of something, yeah, so if you do click on something, at the bottom, it'll give you an insight into what the actual length is. Say if you click through both of those two things, it can sometimes give you some information. You can just use your measure tool over here. So if you hit the measure tool, you can measure a specific component. It'll give you an idea about what's happening, what the area or the perimeter is, a length between them. You can control click between the two of them to give you some minimum distance. And on the left hand side, you've got some options as well. So you can easily see, X, Y, Z, what's the difference between them, what's the radius or what's the dimension between some of these components, right? If you've got the appropriate material properties in there as well, you can do things like mass properties, so you can get moments of inertia. If you can check geometries if there's any problems as well. If you've got two geometries that might be touching, right? So if we move this around, we can use things like the the interface here to check where we might have some interface interference, between the two components, right? And then if you've got something that's quite complex, you can look at things like normals, right? So you can select a bunch of surfaces to pick up where the normals might be. You can look at what the actual grid might be looking at, right? So what's happening around some of these areas, right? Sometimes components come in and there might be some translation issues with the CAD. Again, looking at things like curvature, what components might be, where you've got high levels of degrees of curvature, things like the dihedrals, stripes as well, right? So if you've got a lot of curvature around there, you can easily pick up what's happening because you'll notice around there, right? So there are a bunch of different tools depending on what you need to do in the measure function if you need to go in and make some measurements. Again, alternatively, if you want to actually move something into play, right? You can go to your design tab, use your pull feature. You can pull that with a ruler dimension up to a specific value, right? And you can do exactly the same for the move function as well, right? So let's move this around here. And then what we might want to do is, again, select an axis. We want to use the ruler up to a specific face, and we want to have it 150 mil, right? We can take that, move the actual triad to a specific location as well. And then again, use our move function. You can ruler up to there, right? And again, similar to before, we can go back, move that up to a specific surface as well, right? So if you've got geometry, you need to, muck around within a specific way. You can use the design tools. You can use the pull, the move. You can go in and use the measure tools as well. So another one, so can modifications be performed on in parts too? Yes, we definitely can. So I've brought geometry in. These are SpaceClaim geometries, but we can import actually everything. So SpaceClaim has an inbuilt reader. So if you've got geometry in SolidWorks, you actually don't need to export it out to some other feature. You can just import it straight in. Now I don't have too many geometries. Actually, let me see if I've got some demo models, but to be honest, a lot of them, what I've done is I've gone through and made them all into SpaceClaim models to make it a little bit easier. I just want to see if I've got some step. No, I've got some surfaces geometries, right? So so as an example, this is like an F1 car from the parent. If I bring this is the Parasol, I can just drag it up to the top here. It will generate a new part for me. It's a little bit big, so it might take a second. All right, so you'll notice at the bottom, I've got this component. It brings this part in for me. It's already got some name selections and some components, and I can easily pick something like that up. I can also just go, file open. You'll notice all the different file formats that can natively come in. SpaceClaim has a reader in the background, so it'll just read all of those components in, right? Again, similar, if I've got something like a step file, right, I can bring the actual step file in, and it'll automatically come into the component and create a design. If I wanted to add something to this particular file as well, right, so I don't want to create a new design, you can see all the designs I've created at the bottom. Right, this one's a little bit bigger. Right, so these are all surfaces that's come in, and let's just say, what's my smallest thing? I want to bring in something like this. Instead of dragging it to the top, if I drag it to this workspace, you'll notice it'll get populated on the left-hand side in the actual structure tree. Right, so it'll come in like that. If I scroll all the way down, I've got my component here that's come in. Right, again, I can go in and start to hide all of this. Go to the bottom and you can just focus on that, right? So if you do import something in, I've often seen this happen with IGES files, right? Something will be imported in, and instead of a solid, it's a bunch of surfaces, even though the person exported out a bunch of solids. That translation period, when it's translating between whatever you've got, there might be a problem, right? So there's still some problems here. So sometimes if you might need to go through some of these features, right, and understand what's happening. So can you stitch a couple of these things together? Sometimes there might be you can see here, there might be some small gaps between some of these components, and SpaceClaim will go through the process of fixing it. So if the geometry doesn't quite come in, maybe ask them, don't give them a translated file. Tell them to just give you whatever the raw file format is. You can bring it straight into SpaceClaim, or you can go through some of these repair functions to go in and start to fix some of these components up, right? So now, again, we've still got some problems around here. So what if there you go. So if I hide that, you can see here, I've got a surface around here that's causing me some problems, and it looks like a surface, if I hide this component, surface around here that's causing me some problems as well. So if I actually delete both of them, and I can use something like my gaps, missing faces maybe, my gaps. Right, I might be able to fix it up. So, it's a bit of trial and error. Sometimes the first way of doing it doesn't quite work, and you need to go through the process, understand what's actually gone wrong, right? Clearly, in this particular case, there's something, there you go, zooming in, there's something wrong with the actual CAD. There have been some changes that I've made, and it's clearly created some faces, right? So I can go and hit the delete button, get rid of that. Again, investigate your model. Unfortunately, there's no one size fits all for some of this stuff. Another question. Major benefit of using something like SpaceClaim. Major benefit is that you can just bring anything in. So you can bring in geometry from SolidWorks, CATIA. You can bring it into this geometry and you can push and pull and move the faces, sketches. You can combine. You can use all these tools to fix it, right? Generally, what I recommend is if you've got probably some production CAD or something like that, that you've got sketches that you need to go through and reference again and again. Something like that might be living in a SolidWorks. You've got a feature tree, and someone might want to years from now go back to that specific sketch and make some changes, right? That's where it might live for something like SolidWorks. But SpaceClaim, this is where I'm going to go in, and I use this as a pre-processing tool. So I pre-process the geometry, get all these things fixed such that I can bring it into mechanical afterwards. Right. All right. So another question. Can you export a SpaceClaim model back to an old geometry software in Ansys? I've opened the old model up, but didn't have to go back. So it is not backwards compatible, right? If you do have that type of problem, maybe what you might want to do is you can just save it as save it as something like a step file or a Parasol, right? That way, a step file is neutral. You can open that, say, in an older version of SpaceClaim if you've forgotten, and that's what you can do there. Right. In the end, you'll lose some of the block sketching if you've got that saved out, but you'll have, all your features and all the components and the surfaces and things like that as well. Right. All right, let's go back to a couple of the materials that I've got. All right, so we talked a little bit about creating geometry, a little bit about fixing geometry as well using that block sketcher, right? Now let's go into something like the undersea model here. So maybe you've been given a geometry, something that looks a little bit like this, and you realize, you've been asked to do some FE analysis on it. Ideally, you don't want to be bringing in some of these two geometry, and maybe you want to make some beams out of it. There's a lot of detail around here. You probably want to get rid of that. A lot of these are just plate surfaces. There's nothing special there. So maybe you want to go through the process of mid-surfacing it as well, right? A bunch of different things that we can do in order to fix up the geometry. So let's kind of start with what we've got. And maybe, just to show you guys, maybe I'll have the original model. We'll copy this over and we'll make it independent so we can make some changes to it as well. Right, so let's select this, right click, and we'll hide everything else. So first thing that we want to do, maybe you want to get rid of some of these holes over here, right? So we've seen it before. We can select it. We can use a fill function and it will get rid of it. We can use our box select to kind of select all these faces up, and again, use the fill function in there. But all these small holes might be a bit of a problem. So I can select them. In SpaceClaim, I can go to my selections window over here, and you can see here what it does. I've got two faces selected at the bottom. We can select for different parameters, right? So something of the same color, feature, or in this particular case, radius, right? So I want to pick everything with the same equivalent radius. From two faces, we've gone to 192, and we can use the fill function to fill that in, right? So again, similar into here, we can select that. We can select everything that we want, use the fill function, and it'll get rid of it altogether. In this particular case, we've got a couple of different ways that we can approach this. It's a small emboss. So if we take that face, again, we can pull it up to, right, a specific face to get rid of it altogether. But the easiest way is to just select all of it and again, use the fill function to get rid of it. All right, so there's ways that we can pre-process and make things a lot easier as well. So if you've got a lot of holes, easiest thing, or like bolts, you can select a face. Let's just say we go back and show everything. Let's just say we've got some small faces around here, right? We can select that, use my selection filter, and I want to select all volumes, less than a specific number, and maybe I want to delete them because they might be all small bolt holes, right? So these are different things that we can do. So if we say, let's focus on the bottom structure, right? So let's select all these and Control H to hide them, right? What I'd like to do is extract the actual volume. Sorry, I want to mid-surface this, right? If you go over to the Prepare tab, we've got a couple of analysis tools here. We can use Volume Extract in CFD to extract a volume, or we can use a mid-surfacing tool to extract a mid-surface. So selecting on that, I've got a couple of different options on the left. The very first one, I can just select a pair of offset faces, hit the tick mark, and you'll notice it automatically mid-surfaced the component, right? It also, you can see here, the icons change, so it's suppressed it. So the solid geometry is not going to come into my analysis. It's created this new group for me called mid-surface, and it's actually extracted the thickness out as well, right? So we can individually go in, we can select a specific component, hit the tick button, and it'll get rid of it. Right, so you'll notice it didn't take all the ones at the top there. So sometimes, again, you might need to go in and prepare it. So we'll use my split body function, and we'll split the body, right, using a plane, and that's the plane that I'm going to use. Right, so again, we can go back, use my prepare mid-surface, select two faces, right. All right, let's hide everything else. Let's see if you can mid-surface for me. There you go. And it'll get rid of it altogether. There you go. Right. So again, you can see the two surfaces and components that I've got there as well. What I might want to do, by the way, to make it a little bit easier, because I know, I'll hide this. All of these components at the bottom here, I can select them. I can right click and I might want to move to a new component, right? So this component now then allows me to go in and I can just rename it, right? So now this way, if I ever want to go in, I can hide everything here and just show the bottom component that I've got, right? And I've brought my mid surfaces in as well. Right click, I can hide all suppressed, right? So everything that I've already mid surface, it will get rid of it for me. I can select that one and I suppress that one as well, right? I can go in and then get rid of all my mid surfaces as well. All right, these are the bodies that I've got remaining. So instead of going and manually selecting everything, I can use my range function, right? So first thing I'll do, I'll just pick up, so I've got a radius of around there. I actually want just the thickness, it's around 25 mil. And what do we have around here? 12 mil as well. All right, so I can use my mid-surfacing tool here. I can use my range function. So let's just go from 0, there you go, well, it's already picked it up. And I can just select all of these bodies. It will pick up whatever the thicknesses are within that specific range. And I can automatically go in and extract all those surfaces. So now you notice at the bottom here, if I right click, hide everything that's suppressed, everything that I've got has now been mid-surface for me. There might be some problems here, right? So you can see here we've got a bit of a gap between these two components, right? A couple of ways around it, right? We can actually move that, so we can use our move tool. We can move it up to, so we can move it up to a specific surface, right? We can use our pull tool in a similar way as well, and we can pull that again up to a specific surface, right? I can use my features in the prepare tab, right? There's this extend feature and it'll extend again within a maximum distance of around 10 mil, right? And you'll notice it picks up all of these things in red. I can again manually select them or hit the tick button and automatically extend everything out for me, right? So you can see here all the things that we can do with this actual tool. So again, maybe there might be some problems here. This isn't quite being picked up. The distance is 20 millimeters. We'll go into there, bring this up to say 20. Again, now we've got a couple more features in there. We can extract that as well, right? The other way around it, right? So let's go back to this component. Let's just add all of the components that I've got into a mid surface into my bottom section, right? What I'd like to do, I'm just going to take, say, these 3 surfaces. I'll hide everything else. 1, 2, 3 here. Hide the others. Right. Now, previously I was just individually making some changes. However, the tool can be pretty smart as well. So if I go to that mid-surface tool, I want to use that range again, and I want to select all 3 of them. After I've mid-surfaced it, sometimes in this particular case, it's automatically extended that gap between that as well. So I don't need to go in and actually make some changes, right? Because again, remember previously, if I went in and manually mid-surface that and mid-surface that, right? There's a gap between them. Whereas if I do it all in one go using my range tool, right, you'll notice at the bottom there are some options there. Well, when you do it, it will automatically extend the actual surfaces as well, right? So depending on how you play around with these things, you can very easily, fix up your geometry for you. All right. What else do we want to do? Let's just go back to that. I've got a couple of these components that are just empty. I can right click at the top, delete my empty components, right? So let's focus on just a specific section, right? So let's just take this tree over here. Let's take that. I want to take both of these as well. All right, we'll hide all the others. All right, so the next thing that I might want to do is say I want to extract that beam, right? Going back to my prepare tab of my analysis, I've also got my beam extraction over here, right? So I can hit the extract button, select the beam, and it will automatically extract it for me. You'll notice when I do that, again, similar to before, it'll go into the object, it'll suppress it, it'll create a beam for me with an extracted profile, and I can have a look at all the profiles that I've extracted. and I can edit the profile if I wanted to as well, right? So there's no dimension around there, but I can actually take that surface and say pull it out into a specific value as well, right? So that's how I can again use my extraction tool, right? Again, I can manually click these components, extract all of those out. You'll notice again the profiles have been fixed and I've got a bunch of beams, right? Or I can say select all of these together and it'll automatically extract them. Tell me there are a couple of them that have failed, right? So I've got some problems around here. Similar to before, I can use the extend tool if I wanted to, so that's extended it up to there. I can select that, use my move tool, and again, move it up to a specific point as well, right? And we can make some changes around there. So again, the other thing, again, let's say have a look at some of these components as well. So let's hide the others. What I might want to do is again go through the process of mid-surfacing all of these components. Right, I'm sure what I'll pick up though is that, let's just have a look at, so these are my mid-surface components. I've got my beams here. Again, if there's a bit of a gap here, I can use my move tool to again go in and move that up to a specific component. I can select on something and use my pull tool, again pull it up to there. We can say take that, and I can anchor this into a specific spot, and again move this, up and forth up to that surface as well if I wanted to. Right, so I can extract what I need to, make some changes and fix up my geometry, and then you can go through the process of fixing up the rest of the geometry for exactly what you want to do. Right, so again, if we show maybe all of this, hide all the suppressed, and you notice I've mid-surfaced all the way at the bottom. There might be a bit of a gap here, right? So I can select both of these and move all of them up to that surface, right? Again, it can extract beams and play around with it, right? So I can do that for the rest of the bodies and play around with those features. So a couple of questions: how do we mate the components together in SolidWorks? So what you can do, so if we maybe go back to, let's just get rid of that. So let's exit that. So if I want to mate something, one of the things that we can do, let's just take that and we'll create something, we can play around with it. So we can fill that component. Let's just move it up a bit. And let's just say we've got 3 of them, right? So something like this. There are, by the way, there are a lot more tools. I could have used instead the pattern tool. So if I just delete both of those, I can use a pattern tool. I select this object. I want it to go around there. I want 3, and let's give it a 30 mil gap, right? Instead, let's select the actual body. All right, so I can create that pattern. And the good thing is that I can then go in and start to make changes to that pattern if I wanted to as well. But let's just use the move tool for now. So let's just say I've got something like this. I can go over to my assembly tab over here, right? Let's just say, let's move this kind of around a little bit. I can go over and make things tangent as an example, right? So I can make that, say, tangent with that, right? And it'll move it around, or I can bring that up to that. I can use my line tools. If I go back, I want to align this with that. Right, so it'll move it into place. If I want to, I can even use things like the orient tool as well. So pick a geometry there. I want to orientate it with a specific axis, and it'll move that along. And then you can go in and you can use your move tools afterwards to move things along in a specific direction, change it by an angle. Again, I can move this, so instead of having the pivot point on the object, I can move it, say, from a location, right, from the axes, and move it around that way. I can even change the anchor point as well, right? So if I say change it up to there, now I can move XYZ kind of relative to that component there, right? There you go. Make some changes. So hopefully you can see how you can, if you've got something that's brought in, you can use some of your assemble tools to play around with it, right? Does the move tool work as extending due to other model restraints? I would have thought it moved the whole geometry stuff rather than extruding. So with the move tool, what you can do is it's kind of dependent on the actual feature that you select. So if you select the face, you can move the face, right? If you select two faces, again, you can, move them. If you select the body, you can select and you can move the body around. And again, similar to so, if you, again, just got the actual edge, you can go in and start to make changes to the edge, right? So you'll notice the edge there moves, whereas at the bottom, it stays stationary, right? So the move tool will change. It just depends on what you want to do, right? So it's got the power to change, to move an edge, to move a face, or to move the actual body, depending on what you want to do, right? You can even, put all of these. So let's just say we move this into here. We've got each of these components, and we can, let's just select them, right click, and we can move each of them into their own component, right? So I can just see these three components. I can select my components, move, it'll put it in the centroid. I can move my axes around, right? And I can play around with that as well, right? So I can move, again, you can even select the body, move that around, make a copy of a surface, again, move your surface around as well, right? So it's similar, not just the move tool, but again, because it's based on the actual feature. So if you've got a face, edge, or a body selected, right? You can even scale something up. You can affect the way that feature actually moves around as well. So hopefully that answers your question, Jimmy. Awesome. So yeah, hopefully that gives you guys a good idea, a good understanding about how you can prepare and create some of these geometries in SpaceClaim. What we'll do as well, let's just open something up in Workbench, right? So actually, what I'll do, I'll hit cancel on that. I will clean up this geometry here. Let's just get rid of all this other stuff. I'll show you guys how you can access Workbench from SpaceClaim. How you can just import it straight in, and then I'll set I'll run through. We'll do a quick analysis just to show you guys what we'll talk about in a little bit more detail tomorrow. Right. So again, we can go in and let's delete all our empty components. We can just get rid of all this stuff, and we've got my solid geometry there. So we can leave that as is. Now what I might do, let's just create that surface. I'm just going to pull something out and let's make it a little bit larger. I'm just going to have a body that's kind of come into contact, and we'll play around with contact. So if we've got geometry, we're happy with it. I'll often go through, and make, changes to it, right? Give it an actual name, so you know exactly what you're going to be referring to. And we can just go mechanical R2. It'll ask for a location, right? So test Workbench. It'll save it out and it'll actually fire up Ansys Workbench for me. Center of mass, Mosin. So if you go to your mass properties, you'll be able to pick up the center of the volume is center of mass. Right. You can also get some of these properties in mechanical as well, by the way, depending on exactly what you want to do. All right, so it'll open it for me. It will then bring in my SpaceClaim geometry as well as create a model for me that I can apply then an analysis on. So while that's firing up, I'm just going to go through. I've been trying to answer the questions as they've been coming up, but Just going to have a quick look through, to see if there's anything that I've missed. If I've missed the question, by the way, chuck it in. I'll try to answer it now. I think I've got everything so far. Yeah, we're doing well. All right, so this is mechanical. If you guys, so if we go back to Workbench, you'll notice it just brings in a mechanical model. I've got my analysis tools on the left-hand side, so I can drag in a static structural analysis, and I can apply a static structural analysis. I can even drag in things like a modal analysis afterwards, and I can have a look at the modal frequencies as well. So I'll do a quick run through, and we'll go into a lot more detail tomorrow and talk a little bit more about what's happening in the background. So I'll just normally go through my feature tree. So we've got a ribbon system, again, ribbon at the top. We've got a context menu, a sensitive kind of tree over there as well, sensitive ribbon. So if I change from geometry materials, you notice all the selection icons that I've got have changed a little bit. You can see it comes in, it's got system, I've named it part 1 Bob, and everything comes in. And then I can actually assign it a material over here if I wanted to. There is some more material information over here, and if I wanted to, do some searches for it, it's using Grantor in the background. We can actually start to have a look at, some of these components, and I can actually add it to my analysis if I wanted to, right? I can then go in and start to, add and specify that material. Connections and contacts, right? So we'll be talking about this in a little bit more detail. This has automatically created a contact for me, right? So we've got it between 2 faces here, right? So you'll notice on the left-hand side, I've got that red face is in contact with that blue face over there, and I've given it a bonded contact. We'll be talking about contact in a little bit more detail later on. Let's just generate the mesh. I'm just going to generate the default mesh that's created, right? So it's nice mesh over there. It's using adaptive. I'm just going to turn adaptive off. We'll turn curvature on and generate a mesh again. You'll notice it'll capture the curve around here. And instead of a 3 mil, let's make the default element size around 2. Right. Again, I just want to run through something quickly. We'll talk in more detail tomorrow about what's actually happening here and playing around with some of these settings, right? And let's also change our unit systems to millimeters, all good. All right, so in our static structural, what we will do is that we'll just set up an analysis. So let's just say we take that, I'm gonna select a force, and let's give it a surface direction of Y and just -10. And what I'll do, I'll select this at the top. I'm in environment, I'll give it a support as well. So we've got fixed support. And the other thing connecting these 2 things together is we've got some contact, right? So I'll set it up. We'll just hit the solve button. So we're getting a couple of warning errors, right? Warnings aren't actually going to stop our simulation, but we should have a look at them. I think it's a reference to the material properties, right? So I've got some copper in here. It's got some material properties. Right, there are some thermal material properties, but it's just noticed, I don't have thermal material properties. Oh, I've got some thermal material here as well. But I'm not doing a thermal analysis, so I don't really care. So after the solution's done, we can insert deformation, something like let's have a look at stress. And let's evaluate the results. And then we can start to have a look at things like the deformation, right? So we can observe what's deforming, that's the elastic strain. Let's have a look at the stress. Right, so we can inspect then what the stress of our system might actually be. We can insert what's called a contact tool, right? If we can look at the status, we can look at things like the pressure as well. We don't have any frictionless stress, but we can see here we've got some elements and they're all sticking, and we've got a certain amount of pressure all the way across there as well, right? And because, in Workbench, I can connect all of these things together. After the analysis is done, I can hover over to my modal analysis, right? It's already telling me the pre-stressed is coming from that static structural above. And if I go back to Workbench, again, I'm actually transferring data from my solution of the static structural into the setup of my model. Right, and what I can do, I've got some analysis settings. It's just looking at 6 modes. And we can do a quick solve, and we can have a look at what the actual modes might be for this particular system. All right, so what do I have here? I don't have any boundary conditions. Let's bring this boundary condition over up to that face there. Hang on. So what do we have happening here? So let's have a look at the errors. You don't need large deflections, and that should be fine. Cool. So that's happening. We'll get rid of the pre-stressed environment for now. We can drag over the fixed support. Let's just do a quick solve. Oh, I think I've got some. That's right. That's doing a quick solve for me. All right. We've got a couple of some frequencies here. We can then go in, create mode shapes for everything, evaluate, and we can start to have a look at, what the different mode shapes might actually be, right? And what the animation looks like as well. So we can go no wireframe if we wanted to, right? And start to look at them and what the values might be as well. All right, so we'll go into a lot more detail tomorrow about a bit of that stuff. So transferring data, so just answering some questions. Transfer data between two static analysis in Workbench. So if you have another static analysis, you can say bring it over there, and you can manually say move the geometry over, or let's just say we want to take just the solution. We can move the solution into the actual model, right? You'll need to have, so we'll probably want to move that into the setup instead. So if we've got something like this, we can move that into the setup, right? So you'll need to add your geometry, and what will happen is that you can then start to import and play around with materials as well, but with your forces, right? So you can do an analysis here where maybe you export the forces, or you can do a thermal analysis, right? So we can do a steady state thermal analysis initially, and then look at what the static stresses might be. So there we can link up the thermal results to static structural results as well. So Stefan, because the materials are not able to deform, lead to a non-accurate high stresses at the face. Yes, so one of the things we'll talk about tomorrow. So he was just saying, because we've got a fixed support there, we're fixing all degrees of freedom. We can start to get high stresses around some of these areas. That is absolutely correct. This does come down to a bit of your engineering knowledge and your background of understanding what are the appropriate boundary conditions for what you want to do, right? That comes down to your loading conditions, whether it's force, moment, pressure, and also how it's actually supported as well. So there are instances where, they might have stress concentrations and you're making some sort of simplifications. So it might be appropriate to ignore the stresses locally around that region. If you're interested in that, maybe you then need to go in and add additional geometry or add whatever it's connected through and actually model the connection between that case as well, right? So that does also come down to reviewing the results and understanding what's happening, and do the results actually make sense? And we'll talk a little bit more about that tomorrow. Absolute or relative to each other, Prasad, I'm not too sure there. So the mode shapes will just show you what the deflection is, what the shape is, but you should never use the mode shapes as an actual value, right? So these values don't actually make any sense, right? If you want to understand what the actual displacements, what the actual stresses of a system might be due to vibration, we'll have to apply a harmonic analysis or like a response spectrum. Again, these are things that will be probably talked about in Peter Brand's session, because that will give you an idea. The modal analysis will talk to you about, depending on your loading condition, what the actual frequencies might be. It won't necessarily tell you this is the stress that you're seeing or this is the displacement that you're seeing at all, right? So Mahir, I can transform data from static structural to Maxwell. Again, this is things where if you've got your analysis systems, I don't have the electronics desktop installed at the moment, so I won't see it, but you can start to bring in different analysis systems and we can then start to link them together like we've seen before. Merson, did you just manually put it onto another simulation? Yes, so I think what you're talking about is you can drag the solution information over to separate analysis systems if you wanted to, right? So you can then take, say, the static structural analysis, take the solution and drag it over to something else. Or if you've got your analysis system, you can just move it around and you'll notice there are some green places. You can create a standalone system, or it will share certain aspects of it, and then you can then go in and start to delete, connections if you want to. Right. So Mahid, if you're having problems with Maxwell, maybe have a chat with us on support. I'll add the support email in there. So it's just support@leapos.com.au. On AUST. Send a message to support and just tell us a little bit about what's happening if you've got a Maxwell simulation and you're trying to add it to a static structural and transfer loads over. If you're having problems, let us know and we'll be able to help you out. And that should be good. Cool. All right, so look, those are the major things. I'm just going to have a look through my slides. Yeah, those are the major things that I wanted to talk about with everyone. So hopefully everyone got a good idea about how you can use something like space claim to generate geometry, right? So we can create geometry. We can then use it to go in and start to make changes, right? So we can repair and prepare geometry as well. And we can either bring it into Workbench from this button here, or alternatively, if you've got it in Workbench, you can right click and import geometry in from a separate place as well. All right. And I'll show you just a quick analysis of bringing something into Workbench, setting up a structural analysis and a modal analysis as well. We've got a basic component here. We've been able to apply some materials, tell it what connections, how are these two things connected, start to have a look at things like connections and give it some loading boundary conditions, and then look at the actual results as well. All right. Another question, so if you investigate stress effects of different dimensions from the objects, best way to save time. Different dimensions of the object. I think I'm not exactly sure what you mean. I think so if you want to investigate stresses, maybe from around a specific spot, one of the things maybe you can do is again, we'll talk about this in more detail tomorrow. But you can apply, say, stress analysis to a specific surface, right? So you can select that surface, say, look at the stress, and then pick up what it might actually be. All right. Another way is that you can actually pick specific elements and then display the stress on those elements, right? And one of the things you can do as well is create things like name selections. So as an example, let's just say we select that. We've got a specific centroid over here. We can create a name selection of the, say, a specific size. And if you go over to this name selections here, it'll create this worksheet where it will try to generate, faces with a specific value. You can do something similar where maybe you pick up certain elements or faces, from a location, a Y location, and give it a specific value if that's what you're trying to do. Well. Yeah, what do you mean by change the dimension? I'm not too sure there. So if you want to make it larger or smaller, you might need to set up some sort of name selection. Maybe if you've got a particular problem, let me know. Send us an email and support will be able to help you out. Right. So a couple of additional questions. So Freddie, hey there, Freddie. Solvers, which are the solvers used to calculate the real displacements and the cause of vibration analysis? We read them from the display. So the vibration stuff will be covered a little bit more detail by Peter Brand. The reason for that is that it's a lot more complicated than a specific type of analyses. What I'll just pick up real quickly. So I just want to check if I've got some slides on it. There is a no. All right, give me 1 second. I'm just going to find the right training material just to give you a quick once over about dynamics analysis, because so when it comes to the dynamics analysis, again, Peter will go through this in more detail. There are different types, right? So the modal analysis gives us the structure's characteristics, right? So natural frequencies and the shapes. What we can do, depending on your loading condition, if you want to pick out things like stress or deformation, we can do a harmonic response. So again, if we've got some sort of sinusoidal varying waves and we can actually characterize it in a sine function, right? So my rotating machineries, we can apply a harmonic analysis. A response spectrum analysis, something like earthquakes, right? Where we've got we might have we might have some frequencies and we might have some time varying information about it, right? So this again will give us information about multiple, so short transients, things like seismic events. We can also do things like a random vibration. Again, the inputs that you need for it are all very different. So again, we can look at things like spacecrafts, when things are flying off and on. We can apply things like a random vibration. And then depending on what you're actually after, right? If you're after full nonlinear contacts, you want to look at what's happening, you might need to even take a step up and do a transient analysis as well, right? There are different inputs and outputs depending on the type, right? So maybe, Freddie, if you want, make sure you come to Peter Brand's section on the Thursday, and definitely ask him a bunch of questions around your project as well. Yes, parameter analysis. So yeah, we'll talk about that. Actually, I forgot to talk about that as well. We'll make sure to do that. So we've got a couple of questions more. Ansys can take in Python codes to automate the analysis. Yes, we can definitely do that. So again, all of these are going into pretty deep, but if you, there's a scripting window on the left-hand side. Actually, it might be good to show you this in the latest version, but you can use a bunch of Python scripting to pick up. You can generate your own courses in here as well. In the latest version, maybe I can do that tomorrow. I will open up 2020 R1. You can actually record what's happening on the left. You can actually generate a Python script as well. Materials, and maybe we'll talk a little bit more about some of this stuff in more detail tomorrow. Materials, so you do have the materials information here to go through, or if you go to Workbench, there's materials data, and you can then start to look through the engineering sources that are actually available, right? So we've got materials data from a Granta library, right, which has all this information. We've also got things like geomechanical, composites, hyperelastic materials as well, and explicit materials. So depending on what you want to do, there are materials that can be generated and kind of picked up and created here. All right. What I'll do, I'll just make a quick parametric analysis and show you guys how you can do that in Workbench. I'll create let's just delete all of this. And I'll delete all this stuff as well. Right. So I'll just run a basic kind of beam. All right, I think I've got some parameters as well that I've brought in. Yeah, so that's what I've got there. That's fine. We'll just get rid of all this as well, to be honest. We'll just start from scratch. All right, so let's just say we've fired up Workbench from scratch. I just want to do a beam in bending, and we'll make some changes to the actual geometry. All right. Actually, we'll do like a stress concentration on a hole, and we'll make the hole a little bit bigger. All right, so we'll start up space claim, we'll draw the geometry, and we'll play around with it. Keep asking questions, by the way, if you guys do have. When I've got some free time, I'll make sure to answer them. All right, let's create a rectangle. So actually, let's give it 40 by, I don't know, 150. That looks good. And let's create a circle over here. Let's start off. Actually, let's start off relatively wide. So let's start off. There you go, 30. and I'll use my pull tool, and let's pull this out 5 mil. Let's delete that. So I can select this here, and you can see this P that pops up, and I can create a parameter from it. On the left-hand side, you'll notice it gives me a driven dimension here, 15 millimeters, and I can go in and make that smaller, and you'll see the thing actually change as well. So if we make it 5 mil, right? So let's bring it back and make sure we give it a name, right? We can also make other things a parameter as well. So I can say take the both of these. I can make this larger, and I can make that a parameter, right? But we'll stick with one for now. All right, let's set up a analysis, right? Bring this up into here. We'll start mechanical. In reality, if you're doing this as a project, it's axisymmetric. So not axisymmetric, it's symmetrical. So you wouldn't necessarily want to model the whole thing. You can even potentially do a quarter model of it, but you can even do this in 2D as well, right? All right, so let's just fix this on the left-hand side, and let's take a force on the right, and we'll just give it a unit load in a specific direction, and that should be fine. Just hit F5, and that just does a quick mesh and a quick solve for me as well. Right, so there may be a couple things I can make a parameter. So let's just create total deformation. Let's create stresses. I'll also select that surface and create a stress for me and generate the results. Right, so you can see what's happening. So if we go total deformation here, what we can do is pick up the maximum value here, and we can make that a parameter as well. We can pick up the, say, total equivalent stress, say on that, let's do this one, what the maximum and the average might be across that body. We can pick specific surfaces if you wanted to as well. And we can even make the force a parameter. Another interesting thing, if we go over to our settings here, so let's turn adaptive off, and we have 7 millimeter element sizing. Let's pick up how many nodes as well, right? So we can make all of these parameters. Again, we'll just do a quick solve. Right, again, this mesh is not appropriate, but just for purposes, just to show you guys what we can do. If we go over to Workbench, you notice we've got this parameter set, and we can open it up. All the parameters, we've got the outline on the left-hand side. So we've got input parameters, the hole size, magnitude, and how many, what my mesh sizing is. And I've got deformation, some of my outputs as well, right? So total def, stress, average, and how many mesh nodes. On the right, you'll notice that we've got a design point table. We've got an outline of some of them on the left as well. So what we can do is then start to make some changes, right? So we can say maybe initially leave the results, the inputs for the hole size and the magnitude as is. We can make some changes with the mesh size. So instead, let's make this 6 mil. And maybe we want to go in and let's just make another change where we make it instead of 15. I don't know, we make it 10 mil, right? And I can retain, let's leave the data for now as well. So that's what we need to do. We can just hit yes, it'll close kind of what it needs to in the background. It'll then go through, it'll create these copies for me. It will then, create a copy where the mesh size is 6 millimeters. It'll use the kind of the template that I've given it. It'll generate the mesh, look at the results, and then it'll spit out what the actual results are so I can actually have a look at them. And then afterwards, you'll notice the mesh nodes have already been created, so it's telling me what's happening there. And then afterwards, we'll go back to the original geometry. It'll make some changes to the hole size. Instead of 15, it'll make it a 10 mil hole. And it'll then go through again and make some changes, run the actual analysis, and it'll give me that information as well. So you've noticed I haven't ticked the retain button. So all it's doing is creating it, giving me the results, and then getting rid of the files. If I want to inspect the files afterwards, I'll need to retain a specific value here, and we can set it as current and actually have a look at the actual components, right? So that's how you can create a parameter, right? You can create geometry parameters in SpaceClaim. We can also create parameters around our input files, what our inputs might be, so force mesh size, and have a look at our outputs as well. And then we can do an analysis, compare total depth, stress, what the average stress might be, how many mesh nodes between our different parameters as well, right? So I think, Prasad and who I think that might be talking about the dimensional analysis. I think that's what you're referring to as well from before. I'll show you kind of what's happening there as well, right? And then that should be good. Create parameters options in Workbench. So I think most of we talked about parameters. Special kind of spherical bearing contact. Yes, we do have, again, we'll talk about this in more detail tomorrow, but if we go to our model, we do have contacts and we have joints, right? So depending on how you're modeling it, you can model things like a spherical joint or a revolute joint as well, right? So I'll show, I don't have two geometries, so it's not going to make too much sense. But if we add in a connections over here, you can apply things like a joint. And in that joint, so you need to specify, you can see the yellow tells me I need to give it information. I need to specify two geometries, and then I can give it with the body to the ground, and I've got different joints, right? So I can give like a revolute joint. It can fix specific axes as well. Right, cool. Cool. So another question about parametric analysis. If it's huge and it's taking too long, is there a way to manually solve? Yeah, so we can in the parametric analysis. We can, if you wanted to, right click on something and just update the selected design point as well. All right, cool. All right, so look, I think that's the main things that we wanted to talk about today. I don't want it to go too long because we need information tomorrow to talk about. Hopefully that gives everyone a good idea, just a quick introduction about how we can use SpaceClaim to fix up the actual geometry, to make changes to it and to prepare it for the analysis. And then we can bring it into mechanical. We can then start to play around with the elements, supply it with some inputs, look at the outputs, and even set up a quick parametric analysis, if we want to change geometry or input variables as well. Right. So hopefully that gives everyone